Okay, on this problem, we are to write the equation in standard form, identify the conic and the center or vertex. The first thing I always do when I'm doing these problems is I need to know what it's supposed to be, to know what it's supposed to look like. So I look at this equation and I'm noticing that I have an x squared and a y squared. They both have the same sign. That means I'm either a circle or an ellipse here. Since they have a different coefficient value, this is an ellipse. Since it is an ellipse, I know that my equation is going to have a couple fractions. It's going to have a plus in the middle. It's going to be equal to 1. It's going to have, if it's not at the center, it'll have some parentheses up here. It may or may not need the parentheses. It depends on if it's at the center or not. And then it will have a number down here in the bottom. And when I get to this format, then it will be in the standard form. So I'm going to look at my equation here, and to make it look like this, we're going to use completing the square very often. I am going to first group my x terms together and then my y terms together. So I've got 4x squared minus 8x. Since I have an x squared and an x, I know that I will for sure need to complete the square with those terms. So I'm going to put a little box here for completing the square. Then I've got my y term. I've only got one of those. It's y squared. I don't have a y by itself. So that means that the y's will not need to complete the square, just the x's. Since I'm completing the square, I'm going to move any little extra terms to the other side. So this negative 8 is going to move over by adding 8 to put it onto the other side. And then don't forget, if I'm going to add something here, then I need to add the same thing over here. So that's why I put that little box there to remind myself to keep it equal on both sides. So we have one place where we're going to have to complete the square to get the equation to look right, to have those parentheses that we're supposed to have. The y will not have parentheses around it. So I'm looking at this and I have a 4 in the front. I must factor the 4 out before I complete the square here. So dividing the pieces by 4 gives me x squared. Dividing this by 4 gives me negative 2x. And remember that the square is also divided by 4 to get this number on the end. I'm going to continue in the blue before I go up to the rest of the equation. I'm just going to kind of keep our train of thought going with this here. We're going to write our factors. These factors will always be half of this middle term. So half of negative 2 is negative 1, so it's going to be x minus 1 and x minus 1. Negative 1 times negative 1 is positive 1, so this would be a positive 1. And remember that that's not what's in this box, because this box up at the top was divided by 4 to get that number. So this number, this 1, needs to pick up the 4 from the front before you go up here to this box. So 1 times the 4 is 4 in the box. So I'm just going to simplify this and then work with the rest of the equation. So these, you write it as one of the parentheses squared. And now I'm going to go up to get the rest of the equation. So my y, since I had a y squared but not a y term, I do not need to complete the square with that piece. I'm just going to copy it all the way down. And then on the right side, the 8 plus the 4 is 12, so the right side is just 12. And then I just need to do one more thing. I don't have the parentheses, or sorry, I don't have the equals to 1 that I'm supposed to have, so I don't have my fractions like it's supposed to look like. So to do that, what you do is always the right side is supposed to be 1, so you always at this point will divide by whatever is over there. It doesn't matter what it is, just divide by that. And then for the final step is just to reduce anywhere that has any reductions needed. So right here, anytime you have a coefficient on your parentheses, you need to reduce. So this 4 over 12 reduces to 1 over 3. With the y squared, no reduction will happen, and then the 12 over 12 reduces to 1 over 1, which is just 1. And so we're ready to write the final answer. So the numerator here will be x minus 1 in parentheses squared over 3, because the 12 reduced, then plus y squared over 12, and then equals 1. So this is the equation in standard form for this ellipse, the format that we're used to seeing. And then the center for the ellipse would be at positive 1, 0, which was also part of the question. So we had 3 answers here. The first is that we have an ellipse. The second is the equation format, and then where the center is at. So we addressed both of the teaks that we were supposed to do here. We completed the square, and one of them was use method of completing the square. And the other teak was to identify the conic section from the equation, and that was the first thing we did. We looked at the equation and decided it was an ellipse.